Hi there! Welcome to the video on describing the sequence of transformations on an exponential function that are applied to the basic function to obtain a graph that has had transformations. So here what we want to do is to first compare that we do have functions that are related to each other. So my f of x is equal to 2/3 to the x power. And when we are comparing that to the function that has the other operations associated for that, we want to find that basic structure. So I do have the 2/3 here, and then I have the exponent part, which is the plug-in part over here. I'm just gonna mark that also. So it is that basic structure that matches, and we see that we have the transformations. Now the first thing we want to look for is reflections. If we have a multiplication to the function, that would be that it would be a negative sign. That would be a reflection over the x-axis. But this is a positive 6 multiplied to it, so I don't have a reflection over the x-axis. Now looking in the exponent, I see that where x was plugged in, I have the expression the opposite of x minus 5. So the negative in front of the x term does show me that a negative opposite of x expression is plugged in for the x, and that is showing me a reflection about the y-axis. Now the next thing with the horizontal shift, when we have that negative applied to the term, it's a little bit trickier to identify the horizontal shift when it also has a term associated with it, a constant term. There's a couple ways to do that. So for the horizontal shift, when I have a two-term expression that's been plugged in for the x, as well as a coefficient in front of the x, one of the ways is to take that expression and set it equal to 0 and then solve for x. So here I would add 5 to both sides, get the opposite of x is equal to 5, divide both sides by -1, and I get x is equal to -5. So the point where x used to be 0 is now at where x is -5, showing a horizontal shift of 5 units to the left. Another way to do that is we could have written this where I factor the numerical coefficient in front of the x out in front of parentheses. So if I factor a -1 out of the expression because I have a -1 coefficient in front of the x, that would leave me with, well, -x divided by -1 is x, and -5 divided by -1 is +5. And then I can see that I do have that reflection about the y-axis, that -1 out in front, and then the x plus 5 in the parentheses. Remember, the horizontal shifts are what you would plug in for the x that would make that come out to be 0, and there you can see again that that would be your -5, so 5 units to the left. Okay, how about a stretch or compression? Well, that's back to the coefficient that's multiplied to your function expression, and here that's a +6. 6 is greater than 1, and so this is a stretch. And it's a stretch by a factor of 6. And then vertical shift, well, the vertical shift is identified by the constant term, if you have one. Most times we see that constant term after all of the other transformations on the function. So a lot of times we would see this g of x written as 6 times 2/3 to the -x minus 5, and then -7. And then you can see a little bit better that the vertical shift is down 7. The thing with some functions is that it's a little bit trickier to write it after, just because if the -7 gets too far underneath the exponent, then it starts to like muddy the waters a little bit. Or with trig functions later on down the road, a lot of those, or logarithmic functions later on down the road, we like to have that constant term written first and then the term that involved the basic structure of the function. But doing a recap, we have a reflection about the y-axis, we have a horizontal shift that's left 5 units, we have a stretch by a factor of 6, and we have a vertical shift that's down 7 to get the graph of g of x equal -7 plus 6 times 2/3 to the -x minus 5 from the starting graph of f of x equals 2/3 to the x. Thank you for joining me. Bye.